So in this activity, we will work on with the site-to-site VPN setup. So uh, for us to better see how over IPsec is being configured, we are to work on with this packet tracer activity. So in this topology, in my topology, I have here three routers. They're all connected in the internet, and the requirement is to establish a tunnel, set up GRE over IPsec between R1 to R2 and R1 to R3. I will work on the setup of R1 to R2. R1 to R3 and R1 to R2 setup are similar, okay? So, um, so let's start. So first thing to do is to I'll proceed on part 2, okay? First thing to do is to install this security K9 module, licensed module, in order for our IPsec setup to work, okay? So, uh, better to have a notepad. I'll first write all my config here in my notepad. So, we type this, okay, there, okay, and then I'll indicate this as my setup for R1. So, uh, and then after that, we save, okay. So, let's work on that first. So, again, we need to do this in order for us to install the license security module that we have in our Cisco router. So, we type enable and then conft and then paste. Okay, we type yes in the agreement and then we save. Do copy run start. Okay, this is done in the global configuration mode. We type do show version. Okay, the license module is found here at the bottom. So it says here that it's still disabled, but on the next reboot it will be installed. So what we need to do is to reload. Do reload. Enter, enter. We do that also here in R1. So CLI and then uh, enable conft and then paste. So again, yes. Oh, sorry. Okay, again, paste and then type yes and then save. Do copy run start. Okay, and then do reload. I will not do the R3, okay? I'll just work on with R1 to R2. So now next is we go back to R1, ano? So if you notice, if I type show version, there's already okay, there is already a security K9 installed. Okay, so let me go back to the activity. So we have already installed the security K9. Step-by-step process as we discussed in part 1. We need to first define interesting traffic using access list. So I will copy this. Okay. So this is for R1 to R2. Okay. I'll work on immediately on the setup for R2. So if I were to create an access list for R2 to R1 following this format, this is an extended access list. Okay. So I'll just also use 102. Okay. So this is the network of R2. So that will be the source here, and then the 10.0.0.0 is for the R1. Okay. Next, after the access list is the phase 1, IKE phase 1. Okay, crypto ISACAM policy. We define a policy number here, and then this is where we are to define our security association parameters. Okay, so you assign any policy number here. So example, so for the phase 1, so we are to use AES as our encryption, pre-shared for our authentication, and this is the Diffie-Hellman group. We'll use group 5. And then we need to authenticate peers, right? So we'll use pre-shared. So there's a key. We need to set a key. Our key is Cisco, and we associate that to its peer, to the other router, like in this case R2. So we need to write here the public IP of R2. Okay. So this is for the phase 1. There's a new word there, ISACAP. ISACAP, it stands for Internet Security Association Key Management Protocol. That is the protocol of IKE. Okay. If you Google, it says that they are similar. Okay. In reality, the whatever we discussed during in the IKE, the Internet Key Exchange, that is inside the ISACAMP. Okay, there. So this is for R1. Okay, so as we mentioned, the security association should be, the contract should be same. So we have to set this up also to R2. Okay, but you have to be very careful. What is similar is the encryption, the authentication, the Diffie-Hellman group, and the shared key. But this one, of course, different, right? We have to take note the public IP of the other end. This time it's R1, so it's 192.168.118.2. There, done. Okay. Next is for the phase 2, phase 2. We copy this. Okay. So again, for the phase 2 is, the agenda for the phase 2 is for the payload, for the data. Okay. This one is for the established connection. Okay. So for the data, we define a transform set using this setup. Cryptos IPsec transform set, we set a transform set name, and then for the payload, our encryption is AES, and then for the integrity, we use SHA, a hashed algorithm. Okay, and then there. So this is again for the phase 2. After we do all of this, phase 1 and phase 2, next is we have to define a map. Okay, we place everything we've done so far in a crypto map. So we set a crypto map name here, and then here is the policy number that we've set, 102, and then we type this IPsec ISACAM. Okay, inside the map we set peer. We type here the public IP of the other end of the router, R2 in this case. Then we define the transform set. Transform set, this is the name, right? This is in this name, this is where we say that the under phase 2 we are to use AES and SHA. Okay, and then next is the match address. This is the access list number. Okay, so as for the phase 1, this one, that is the one that defines the phase 1. So we bring everything all here together in the crypto map. phase 1, phase 2, the other end of the router as an identifier, and then the access list. After this is we apply it in an interface. We apply the crypto map in an interface. We go to the interface of the router to where the internet is connected, and then we type there that crypto map and then the map name. So I copy this, okay, to R2, and there, double check. Then here we change the peer, right? So this time it should be 209.165.118.2. Okay, and I think everything is set. Okay, there. So done. Next part is I'll move on with the GRE. So for the GRE, we set a tunnel interface. We first do this to R1, and then next is we set the IP ad for the tunnel. So the administrator of the company used a 192.168.0.1 as for the IP. We define the tunnel source. Okay, tunnel source, and then tunnel destination. There are some of you, I think older batch, may have covered this during your Cisco, but I'm inserting this in the cybersec because this is a good activity. So sort of a review also for those who had this before. And another, I think last term, because last term was, in my opinion, a mess. So that's why I am discussing this here. Okay, so there, done. This was a topic actually in Cisco 4, but in Cisco 4 the IPsec is not discussed, only the GRE. So I copy this and then paste it here again, but not everything are the same. The tunnel 0 for R2 is 0.2, and then the tunnel destination is for R2 is yung 209, yung public IP of R1, 209.165.118.2. Okay, done. So after this is you need to a router should know that the 192.168 does exist, so we need to define a route. Okay, so example ha, let's say we go back to R1. So we have to say, hey R1, if you are to go to 172.16.0.0, this is the network of R2. Okay, with a subnet mask of 255.255.252.0, you use the tunnel interface, which is 192.168.0.2. Okay, next hop, right? IP add of the R2 of the tunnel series, IP add of the tunnel interface of R2. Okay, so we do this IP route also to R2. So again, we tell R2, hey R2, if you were to go to R1 and its IP add is, or its network address is 10.0.0.0 with a subnet mask of 255.0.0.0, you use the tunnel interface, which is 192.168.0.1. Okay, we've reached the end, so we copy this from here, uh, here, go to R1, enable conf t, and then paste and double check. So I hope there's no error. So there's the access list, there's the policy name, a policy number, sorry, the pre-shared key, transform set, and then the crypto map. And then we have here the GRE part, and then the IP route. So, and then we go to R2, R2, copy this, go to R2, conf t, and then paste. Okay, enter, and then double check. Okay, so if there's any error, and it looks clean, okay, we check the show IP interface brief. We have there the tunnel, and it's good that it's up. We are expecting that. Another, you should be able to see the 192.168 in the routing table. Do show IP route, and we do have here the tunnel. Okay, there, tunnel. So now, we check. We expect that these two the end devices are connecting. We have an end-to-end connectivity. So L2 should be able to connect to the server, and there is we have a successful connection. Okay, we trace route. We check uh, if uh, if it goes into the tunnel. So I go here to PC, desktop, command prompt, and I'll type trace route 10.0.0.2. And if you notice is, first of course it goes to the default gateway, and after this is yun, na disconnect. Okay, let me do that again, fast forward. Okay, let me first again trace route. Okay, let's try. It's successful. So we check, do show run. Let's see what happened. Maybe something, there's a part where we miss something. We look into the tunnel interface. 209.165.118.2. Go here. Do show run. Okay. We have the access list. Okay, and then /8, tama ba? And then the IP route. And then the tunnel 0.2. Tunnel should be 192.168.0.1. Tunnel source 64.113.2. Okay. I'll try here. Okay. So, uh, do trace route 10.0.0.2. There's the 192.168.0.1. It's working. Okay. Uh, IP config. So, try again. Sorry. Trace route. And there, there's just a delay. So we see now the 192.168.0.1, which is the tunnel. Okay. So whenever this PC here goes to the other side, R1, uh, we do not see the public IP. What we see is the tunnel interface. That is a proof that the GRE is working. Okay. In the IPsec, there's a command for us to know if indeed it is encrypting. It's a show crypto IPsec SA. We simulate that show crypto IPsec SA in an actual router okay. So this ends this activity. Okay. And thank you. Keep safe. You are to work on with this activity for this week.